I'm Damir Majer, and welcome to my talk, Back to the Future by Adopting OO in ABAP Objects. So, I hope you're having fun in Vienna. So, sadly, I can't hear you, can't see you, so it's really some kind of inner dialogue, but I think you will have fun, and I'm having fun here, so that's perfect. Yes, and it will goes like this. I'd like to share with you some tips, tricks, and programming techniques specific to OO, object-oriented programming, that I have learned over the years, and I hope there are some developers in the room, and yes, maybe first you can fill some messages in the chat panel so that I'm getting some kind of feedback. This would be really kind. This talk has 3 sections. First, some intro, then we'll explore the rules to clean and good OO, and finally dig into some example part, really some kind of beginning. And those topics are, from my perspective, really important. They're evolving in the SAP world, so a lot of things are changing, and also maybe some really old stuff like good old programming could be something that matters. And I will stay, and in 30 minutes maybe we will finish earlier because the slides are created for an on-site talk, so could be that it will be go faster than expected. And yes, then we could start. Only switch off the camera, and perfect. Yes, Back to the Future. Pretty interesting title, isn't it? And yes, why Back to the Future? Yes, zoom back 3 days ago. So this was the yes, this was the situation that I have to manage at home. And okay, it's my living home. There is some sofa, some kind of everything is there, and it happens if your exercise topics are all around the room, yes, then it could be happen some kind of incident, and the incident happened. So I knocked with my toes and got some kind of capsule foot injury. Okay, I was thinking this is really fun, and why? Okay, the situation could also be like this: keep the core clean. And during the last weeks, I heard something like this: keep the core clean, keep the core clean. And I think there are a lot of situations where this proverb could be adapted. One is, for example, my living room. Now it's really healthier for me to make some work. It's more secure, and this security, and maybe also I can walk a lot of faster. Maybe this is also relevant to good old programming stuff, and SAP is using heavily this object-oriented paradigm, and I make a deep dive into this topic. It took approximately more than 10 years to figure out some really fancy stuff, and today I'd like to share this. Yes, what I collected over the past 10 years, and it looks like this. I call it not only OO, I call it applied OO. Why applied? Yes, I'm from a person type, really someone who's pretty pragmatic. So I'm not a theorist or something like this. It's everything I measure on the scale. Can I adopt it? Is there any benefit out of this? And uh, yes, it took me some while to really also adapt all the rules, and also to measure in the direction, does it work or does it don't work. So we have here a lot of fancy stuff. The uh, green underlined names. There are some maybe important people in the IT industry, in the computer science industry, and yes. So we will start with the first rule, and the first rule is okay. It's derived from the early 60s and the late 60s. What is the goal of this OO? And who invented really the first ideas in OO? Think about it. Think about who invented OO. Do you know the names? Do you know the goal? Okay, sometimes I'm asking also some students of me, do you know who invented this stuff? How could you measure and understand some topic if you don't know the primary definition, the primary goal? And this is also the reason why I'd like to start with this mental model. So the two Norwegian, Ole Johan Dahl and Kristen Niegert, they worked at the Norwegian Computer School, and they have to do some physics job. They have to measure some, I think, something related to atom bombs. And okay, for sure, they have to think how to simulate this. It is quite crazy for everyone to simulate such kind of um, a topic, and the simulation that they're uh, that they're thought about was transferred into a programming language. And the first programming language with some object-oriented topics is similar one. After some couple of years, they invented similar 67, and on the right side you see some similar 67 code. It's quite beautiful. You identify some kind of stuff like classes and some refs, and why this mental model matters. So everything we construct in computer science as a developer is derived from a mental model. Maybe my mental model is different than yours. A short example: think about a villa. Yes, something, some kind of mansion. Okay, when you think about it, how big is this mansion? How many doors? How many windows? So is there uh, some some pool behind, some garden? So you can imagine that everyone has something different in mind when we think about a mental model. And this is also the reason why, especially in object oriented results, uh, there are a bunch of different ways to solve some problem, and every way is completely fine because we are really different, and everyone thinks in a different direction. So this is the rule number one: think about your mental model. What is the main goal here? What you like to build? Maybe grab pen and paper and don't start immediately to program some fancy stuff into your favorite environment. So it's the first step is think about your topic, think about the model, think about really about the problem. The next topic, it's derived from Alan Kay. So Alan Kay was in the early 1960s a student, and he had the option to met the Norwegian computer club, and to met the both inventors of similar 67, and he saw some fancy stuff. After his visit, he started thinking. He had a big interest in biology, and okay, it took maybe some months that Alan Kay started to define what is object-oriented programming. He's really one of the fathers. Sometimes he was mentioned as the OO father, but okay, we know from history he is not the first who has thought about such kind of things. And on the right side, you see his definitions. And okay, I took this definition really serious. So everything is an object. Okay, if we do object-oriented programming, we have to think about this objects. Okay, it's not object procedural programming, and it's not object functional programming. It's object oriented programming. This means, okay, try to find out some kind of objects. Think about living objects. Think about this topic that we should work with objects. The next really pragmatic topic for me was this: every object is an instance of a class. Okay, this started maybe a couple of years when I've mastered the advanced topic of object orientation, like inheritance, events, and interfaces. And at one moment I realized, okay, there are some syntactical statements that support some flexibility, and there are some syntactical statements there decrease this flexibility. And really one of this main topic is, if every object is something living, then we should get rid of every static statement, like static data, like global data, like static methods. Okay, it's not the main definition or the origin definition from Alan Kay. And further, I will only use this AKD as the reference. So it is meant that we use instances, something living, something that we can mold and maybe change his behavior. For example, if you have some kind of inheritance, like this. Okay, there is some, okay, vehicle, and something is inherited from this vehicle, maybe a car. Then we have also some methods, maybe something like drive, and this hashtag means it's protected. And such kind of statements should be instance statements, because only instance methods could be redefined. Think about this. Think about this flexibility, and about also what should we change in the future. The next part is pretty easy, but it's maybe it's the most important stuff today. So Alan Kay mentioned on his second rule, objects communicate by sending and receiving messages. A couple years later, Alan Kay was interviewed, and okay, some kind of questions arrived like, "Hey Alan, how satisfied are you with your object-oriented stuff? You are a hero. Everyone in the industry is using OOP, for example, C++, and later on Java." And yes, his answer was pretty interesting, because first of all he mentioned, "I'm sorry that I long ago coined the term objects for this topic, because it gets many people to focus on the lesser idea. The big idea is messaging. Yes, it's messaging again. The and from this idea, he also mentioned it was really an error to call it OOP. The better name is message-oriented programming. And for example, you like to navigate me to some place. Then you're not navigating me via the nouns. Okay, here is a building, Damir, and then there is the sun, and a lot of cars are parked here. No, you're navigating me like this. Go straight, turn right, go 30 meters. Please look at the left and at the right, and if the street is free, then you can cross this really risky street, and then at the end you reach your goal. Okay, we explain stuff in verbs, not in nouns, and it's pretty easy to understand that this works like maybe the model that Alan Kay has in mind, because this is so natural. And if you start constructing your software starting from the messaging part, then at the end you will find your objects. For example, here is the turn object, and here is some street crossing stuff, and here's the domain that is relevant. So your objects looks at the end completely different. And now, or at this moment when I get this point, I understand why it was so difficult to have designs that are produced only via these objects, only via class names. At one moment that really doesn't fit, and there couldn't be wired. And the reason is, okay, the reason is it's not natural. More natural is, what is your path? What is your way? What do you like to achieve to solve this problem? Next definition from Alan Kay is objects have their own memory. Okay, we know this. Yes, from OOP 101. Objects are constructed by some functionality and some data. This data should be protected like a biological cell, like this picture on the left. So it should be really should be encapsulated. Only the functionalities should speak with each other. So the messages should speak with each other. For example, if I like to shake my hand, then my brain is starting to messaging some kind of rules, some kind of command, some kind of order. And the command could be, hey, please, from the brain, please shake your hand. And this information is transported via my arm, via my shoulders, via some neurology net. And at the end, someone will understand this message, maybe my hand, and the hand will start to shake. Hey, shake, shake. Okay, so there is some data, and especially in the SAP world, we often forgot this, but business software is often data-driven. Nowadays, data is the new gold. So understand your data. Treat your data really serious. From the lowest possible level to the highest level. Encapsulate. Think about some accessor, some kind of API. So if your core is clean, especially at the beginning of your program design, for example, like this. If this is clean and this matches, and we can construct out of smaller stuff some bigger stuff. Oh, sorry, some bigger stuff. Then maybe at the end, how to say 1 and 1 is more than 2. Okay, think about this. Could be pretty interesting. The next topic, it's polymorph. Okay, we know this. Object orientation has some special functionalities, and everyone in the industry is thinking about this extensibility, about this adaptation. And maybe this is also the reason why some kind of famous developers like Uncle Bob, Robert C. Martin, he's the author from Clean Code and the Clean Coder and a bunch of other books. Why for him is object orientation only the thinking about polymorphism. What should be changeable into my solution? What should be replaced? What is the next requirement that should be adapted? If you construct solutions with this kind of questions, then you will see that your solution becomes more and more flexible, becomes maybe extensible. It becomes a stamp of polymorphism combined with OO. And this polymorphism, for example, in ABAP Objects, we can use some kind of inheritance with normal classes, abstract classes, some kind of interfaces, maybe compound interfaces to make everything responsible for their own. Then at one moment we have maybe software that looks like Lego. You know Lego, it's like this, and from Lego you can build really some fancy new stuff, a new building. And if you don't like this, then you can make some additional stuff, and at the end, ooh, we have a car. Okay, small pieces can be combined to bigger results, and this is nothing new for our industry. Couple of years, this term microservices was so popular, and at the end, we as a community understood, okay, if you like to have good microservices, your lowest level has to be constructed really clean. It's impossible to build upon a bad foundation something good and robust, something valuable. It's impossible. The next topic is loosely coupled. Okay, why loosely coupled? Why this matters? Why it's not enough to only have working solutions, working software? Okay, what is sure is that at one time some new requirements will pop up. So this change is really something that we can rely on. And if we construct our software too tightly coupled, then this change will be impossible. But we know a lot of techniques that supports this loosely coupling. For example, a lot of APIs are really good constructed and are really a good lesson to deep dive into this topic. But also in our good old ABAP and ABAP objects, we have this body implementation, this possibility to extend something that is not tightly coupled between the code. So, for example, It could go like this. You have a class. Oh, maybe I choose white. I'm not sure. I know. Or red. You have a class. And this class A, is tightly coupled to class B. Okay, and every time I'd like to extend or change in class B, also all the callers has to think about, okay, how to extend, is the coding still robust, do I have to change, and often you have to change something. So the solution is decoupling, goes like this. So we have a class A, and decoupling goes all the time with one issue. We need to introduce more structure, more levels. This level could be an interface. And now also the direction changes. So there is some indirection, and this is really the foundational knowledge to start to think about loosely coupled, about messaging that's so easy. Yeah? This is one way, and this is only the beginning, that you understand this decoupling from the source entities. The other way, loosely coupled, you know, from event-driven programming, and this is really supported now since 740 with ABAP channels, ABAP message channels, and even before we have these events that are so flexible. But often I see, okay, there is something like this, but no one uses. It's too complex. It takes me 5 minutes to understand. Okay, sometimes 5 minutes are really worth invested. Symmetry. Oh, this is my absolutely favorite. It took really a lot of time to understand this symmetry. I heard a lot of talks, and really some masters of coding like Michael Feathers, who wrote this book about legacy code, and Ken Beck, who invented the first unit testing framework and test-driven development. All the time they are talking about the symmetry, and I don't get this point until I realized, okay, there are a lot of variations of symmetry. One variation could be, here you have production code, and on this side, test code. And really, your ideas here should match with some test code. This is one topic. Another topic is, imagine you have a big class. Yes, maybe one class and one big method, so-called God method, main. And you realize, okay, really if you look at this main method, we realize the coding behaves really weird. It's not so beautiful. There is some problem. And 1 second. Okay. And okay, so there is some kind of symmetry, and this symmetry also belongs to the size. So how much statements do you have in your methods? How many ideas your method represents? And at one point, it goes really along with the SRP, single responsibility principle, that your coding shouldn't do too much. It should do less. Okay, this is my favorite. Also, one of my favorites, avoid cowboy programming. So it's not enough only to program some stuff, make the last dot, and then say, UPIA, I'm ready. Next requirements, come on. And this produces really a mess. This produces legacy code, and legacy code is on the mid and long term really costly because some experts have to transform such kind of mess into something usable. It's not testable, it's not extendable, so it's a problem. So avoid cowboy programming. And also avoid thinking in instances. It's not the commander, it's not the alpha grid. Think about who is using your stuff. Yeah, it's a financial report. It's some completely different when you think in roles. And this role-based thinking, I have these ideas from domain-driven design and from the inventor of the model view controller patterns. They are really thinking serious about this roles, and this produces complete different design. Okay, so this was the applied OO overview, back to the future, so we can learn a lot about the history, and here's some information about me and maybe one topic. So soon there will be announced a new community format. Yeah! And stay tuned. There will be a blog and there will be an announcement. Follow me on Twitter. And yes, so that's all. Finish. You survived. Thank you very much. I wish you a great event and hope that you're not falling asleep. So greetings here from Munich, and yes, till the next time.